Hi, so I will be doing problem number 2 as my personality test score resulted as a 2. So part A asks, what must the charge, sign, and magnitude of a particle of mass 1.4 grams be for it to remain stationary when placed in a downward directed electric field of magnitude 610 N over C? So, to start with the charge itself, actually, it goes in a downward direction as stated in the problem itself. So for me, I am able to tell that it's going to be in the negative direction hence it's going down. And then using the equations from chapter 21, there is force equal to the magnitude of the charge of the particle itself times the electric field, or the electric field, which the force is actually equal to mass times acceleration. So in that case, here we will put Q times E will equal themselves. We'll just substitute them out. M times A. The acceleration is actually given to us. It would just be the gravity itself of 9.8 meters per second squared. And we are trying to solve for Q. So we're just going to divide over E, and we'll substitute A for G. So then that becomes Q is equal to mass times gravity over E. And then I have written each, based on the problem, what each variable is. So then we'll just substitute at that. 1.4 grams turns out to be 1.4 times 10 to the negative third kilograms. And that's going to be multiplied by the gravity of 9.80 meters per second squared, all divided by the 610 N over C. And of course, I just want to check with my calculator. So then we're just going to do 1.4 times 10 to the negative third times 9.8, the gravity, and divide that by the 610. So my answers, and I'll round up after the 2.4, so the 9 is going to make that a 2.5. Answer is going to be approximately 2.25 times 10 to the negative 5. And your units will just end up being C, as the kilograms times meters per second equals a Newton. Those will cancel out. Now part B is very similar to part A itself, but this time it's asking for what is the magnitude of the electric field rather than the magnitude and sign of a particle. And apologize, I mentioned earlier it's going to be a negative. Okay. What is the magnitude of an electric field in which the electric force of a proton is equal to in magnitude to its weight? Similar to up above, I'm just going to write the Q E is equal to the mass times acceleration. This time we're solving for E. So instead of Q, it's going to be E equals mass, and acceleration is just going to substitute for gravity. So mass times gravity over Q. And then again, substitute in. We have the mass given to us, which is 1.67 times 10 to the negative 27 kilograms, times gravity again is 9.80 meters per second squared. That's all going to be divided by 1.60 times 10 to the negative 19 C. And as mentioned, kilograms times meters per second squared is going to be newtons. And as we go again on the calculator, 1.67 times 10 to the negative 27 times 9.8 divided by 1.6. I'm actually going to put this in parentheses. 1.6 times 10 to the negative 19. And I'll just stop at the 0, 2. Okay, approximately 1.02 times 10 to the negative 7. And this is just going to be newtons over C. Thank you.